Hello, everyone, and thanks for joining me. Today, I'm going to be covering a new topic, and this is related to Suncor's Firebag asset, and it's also known as the crown jewel asset of Suncor, and I think it's an important one to talk about. Please see my disclosure here. The nature of the asset is going to be a little bit more technical, and we're going to be covering kind of the Directive 54 performance report and providing details from recent data that I was able to collect. So Firebag project is a commercial steam-assisted gravity drainage project. They basically inject steam into the formation and able to reduce the viscosity of the oil so it can be drained by gravity. So it's located about 120 kilometers northeast of Fort McMurray, and it's been operating since 2003. Average bitumen production for the reported period back in 2024 was about 34,455 cubes. Today, this amount is closer to 40,000 cubes, so closer to 250,000 barrels a day versus 217,000 barrels per day. So one thing one would notice is the kind of growth opportunity. Soon we're going to be seeing exactly what the dynamic there was. And steam to oil ratio is 2.72 as of that time frame, 2014. And I'll provide an update to what it is now. And that's really a metric of efficiency and kind of asset geology, because that really what tells you is that that's how much steam is required to produce 1 barrel of oil. So how many barrels of steam required to produce 1 barrel of oil, or how many cubes of steam required to produce 1 barrel of oil. So that's kind of a volumetric parameter. So as we look into the subsurface scheme performance, you can see from 2003, Firebag stage 1, they started kind of producing the asset, they build the surface facilities, and Firebag stage 2, they were kind of getting closer to that 5,000 cubes a day production rate. And their biggest event for this asset really was around kind of 2009, 2010, where they took this next step towards Firebag stage 3, where the steam injection capabilities went from 30,000 cubes to about 80,000 cubes a day. And you can see the significant jump in steam utilization. Also, you can see a significant water production rate in blue, steam injection rate in red. And that expansion really allowed the asset to grow significantly towards what we see today at roughly 250,000 barrels a day. This month is about 244. And over the course of time, from 2009 towards 2015, into the very strong oil prices, we're seeing ramp up in oil production rates, going into those levels of 217,000 barrels a day, 230, 240,000 barrels per day. And the well count is also increasing. So the question is, like, how is it that SOR stayed similar or actually even declined while the well count increased? So what you also can see in this chart is the NCG co-injection strategy. So they, in gray, they inject non-condensable gases. Those are for late life kind of pads to pressurize them and maintain the bottom hole pressure in those wells and pads. And but you can see kind of like even here towards 2023, they're already able to have about 325 producers. So as of today, this asset. So right now I'm recording this. I'm talking about this. It's end of 2025. So we're quite a ways away from what this chart is showing. And production actually on this chart in green, if you look at the green chart, we're closer to 40,000 cubes a day, so close to 250,000 barrels per day. In fact, for the month of October in 2025, production was about 244,500, but obviously there is a standard deviation to this, and it fluctuates. The month previous to that, production was 246,000 barrels per day, closer to 247,000 barrels per day, and there was a small decline by roughly 1%, and that kind of speaks to the standard deviation number associated with production oil rate. So often investors would look at the oil rate and will say, oh, production is declining, it's down 1%, what's going on? Well, it's actually normal, so it's not a big deal. The overall number of producing wells on the asset was 338. So on this chart, you can see about 325. So obviously they're very good at drilling new wells and kind of integrating NCG in other wells, and maybe taking some older wells offline and integrating new ones. And average production per well was about 723 barrels per day. And that's an important metric because it kind of gives you an understanding, okay, the overall asset is producing 240, 250,000 barrels per day, but what's the average well producing? And that's a little bit higher than 700. And that's why I went to the Canadian Heavy Oil Association conference. I think it was, it was last month. And one of the executives for Suncor, she said that Firebag is their crown jewel asset. And you can see why, right? Like if you have such good productivity per well, and you only have like about 340 wells producing, 700 barrels per day, that's very significant. And their ability to integrate NCG, non-condensable gases, and kind of maintaining lower SOR, it's a very good indicator. The best well, by the way, producing much higher, right? So there is a standard deviation around that. And about 147 wells producing kind of below the average, and 190 above the average, and about 199 wells producing below the average of 723 barrels per day. And the top 147 wells producers produced over 70% of the overall production on the asset. And that really tells you that as the steam chamber kind of expands vertically, they're able to bring the production from those wells, which means there is ongoing program to bring new pads online and non-condensable gas co-injection, as you can see in this chart, in late life pads. So current injection of NCG is about 150 SM3 per day. So that will be 150,000 decks, right? If I'm not mistaken. And you can see they actually like lowered the NCG co-injection a little bit from 2019 levels. And that tells me maybe they're trying to kind of control the subcool, basically liquid level on top of the producer, and kind of gas production rates, and keep it somewhat mitigated according to their operational strategy. Also, the top 5 wells, they produced a significant amount of the production. So I'm not sure if it's like on the pad basis that they're reporting, because sometimes Suncor had this configuration where they reported on pad, but it tells me here that just under 5% of overall production coming from very few wells, which tells you about the very high productivity of those wells. And it could be a cluster of wells that they're reporting as part of their kind of reporting to Alberta Energy Regulator. The average injected steam rate, which becomes really important, and you can see on this chart, it was actually over 100,000 cubes a day, right? Which makes sense. So that will be just north of 620,000 barrels per day of steam injection rate. And you can see, so their current injection rate is 627,000. And now if you take this kind of aggregated steam injection rate for all the wells and divide by aggregated oil production rate, which is 244,000 barrels per day, you get the SOR metric, which is 2.5. Now, if we go back here, they indicated that their SOR is 2.7, so steam to oil ratio. So how come we produce more now and SOR is actually going down? Well, that speaks about the operational strategy and the kind of really good ways in which Suncor is able to bring their assets online, bring their pads online, bring the NCG co-injection online, and really utilize the technology to lower the emissions, to reduce the steam requirement to produce 1 barrel of oil, and really lower that energy intensity and enthalpy required. Now, for my calculations here, I don't see as much infill integration program. So infill well will sit between 2 well pairs, so injector producer, and you will have an infill in the middle. And I think in my view, this is an opportunity for them to utilize infill well integration into the future. As we kind of look historically, we quickly realizing that their SOR is declining, the well count is kind of stabilizing or increasing, and they do much more with steam that they were able to do prior to that, which tells me they're very good at optimizing their assets and kind of advancing new methods to control their wells when it comes to subsurface. Now, from a historic point of view, if you look at the SOR, it's already been declining here since 2004, but that makes sense because once you start kind of circulating the initial wells and kind of allocating and closing that material balance, the SOR will be kind of initially maybe picking up, which is what we're seeing around 2011. But then they were able to kind of integrate technology, and the cumulative SOR is actually declining. So it's closer to that, I guess, 2.5 mark right now as we speak. In this chart, it's closer to 3. So that also tells you, again, they're pretty good in kind of integrating NCG and operational strategies, maybe better completions, better spacing between the well pairs. When it comes to water to steam ratio, so that will be the blue chart, we're closer to 1. And from recent data, I'm seeing this number is 1.07. So very close to 1. So what this tells me is that they're able to control their material balance when it comes to water utilization, and basically maybe producing that and re-injecting in the form of steam. So that's a really good indicator. It's very stable. This also tells me that maybe they don't have as many complex geology when it comes to maybe top water or bottom water that maybe can inflow into the wells. You do see a slight increase over time from 2006 at 0.9 water to steam ratio, but it's kind of around 1 now, so it's stable. So the team is able to mitigate this and control this operational strategy when it comes to water cut, water to steam ratio. And a couple more updates. Their water cut, when we speak about this, my calculated water cut is about 73%. So that's very good. That's one of the lower water cuts in the industry. And what that tells you is that the partitioning of water within the emulsion that's being produced at the back, that ratio is stable, and it's actually on the lower side. Again, speaks to the geology and kind of the opportunity there to optimize the asset even further. So now, as we look into their drilling in the approved drainage area, we can see kind of the cluster of the pads where they're operating, and we can see some areas that were approved and the drilling opportunities as they kind of integrate, bring new wells online, and NCG co-inject the legacy wells to maintain bottom hole pressure for coalescence. Here we can see a reservoir isopac map. You can see the thickness depth of kind of the reservoirs where they're located, and obviously you will see a lot of legacy pad integration, because what these companies do, they typically go into the cleaner zones and trying to exploit those assets. And now you can see them kind of going more west to the areas where the isopac, the thickness of the depth is higher, to develop those wells and maintain that low steam to oil ratio. This is a map of a continuous reservoir structure map. You can see the kind of elevation depth. So they initially go to maybe shallower reservoirs. As you go west, you obviously go a little bit more into depth, but east you get even deeper, so 340 meters. That really speaks about the opportunity really to, in the future, to start kind of accounting for what will deeper drilling would be costing, and what that kind of incremental geology looks like as they get lower. But obviously that explains a lot to why this team was able to kind of concentrate initially on that area. And you can see west, you can go even shallower as you kind of develop your pads and you go into those areas. This is top continuous reservoir structure map. Obviously good continuity around the kind of the reservoir structures, and we can see the relative elevation. And obviously the shallower kind of locations are more they were more opportunistic, right, from that perspective. This is reservoir zone gas isopacs. You don't really want to have top gas or bottom water or top water going into the reservoir, because once you start injecting steam and steam is expanding and growing, the steam chamber, you basically can connect to different complex geologies, and that gas could start short-circuiting and going into the producer. And what we see here, we do see some pockets here and there of different thicknesses of gas locations, but we can see how the team was able to kind of initially from the legacy pads to entirely avoid those areas. But then we can see kind of slight pockets of gas locations, and which could be explained by higher gas to oil ratios and when you get the production from the areas. And if you see a little bit more kind of south, you can see the big pocket of gas that's located. That's really unrelated to non-condensable gases, but that initial gas, you really want to make sure you control your subcool and kind of better mitigate these areas to avoid any concerns in operational strategy. So gas zones are inconsequential to Firebag, but are included for reference, as you can see kind of in this chart. Water and lean zones, so they, as I mentioned earlier, and mainly because of the data, they don't have no top or bottom water zones have been identified within the Firebag development area. We can see that in the data as well. Upper lean and middle lean are present in some parts of Firebag development area. We also talked about that a little bit. And there's more information in there are some documents that are applied for. Now, if we look for geomechanical anomalies, there are no geomechanical anomalies within the Firebag development area. Anomalies. They monitor heave monitoring is performed using interferometric synthetic aperture radar, INSAR. So the idea here is really to see if the ground is moving, and they're basically monitoring for that. So that's basically what they're telling us. This data is used to calibrate geomechanical models as well as to monitor subsurface safety and flag areas that appear abnormal, essentially. So good job by the team here, kind of monitoring the asset to see if things are shifting at surface, and seems like they're doing a good job. Caprock integrity assurance, again, this is a very regulated industry. You have to really make sure that you kind of control your bottom hole pressure and you don't exceed the pressure when it comes to Caprock integrity. And so they have one new micro frac well, Suncor Firebag, to assess the clear water, one new Caprock core collected during the reporting period, and geomechanical simulations are developed to assess the all new pad startups. And so they basically do reservoir simulations to plan a new pad integration. And here they're basically telling us that they have a geomechanical model and simulations they conduct to basically account for geomechanics. And this activity is confirmed that operating at the approved maximum operating pressure, which is called MOP, does not impact Firebag Caprock integrity. So that's really good. You really want to avoid any situations where you exceed that bottom hole pressure. Fracture closure gradients. So you have different fracture closure pressures. So I guess some terminology they're using here, and they use target formation. So talk about McMurray, Wabasca, lower clear water. So basically different pays, and they monitor those as well. They do some seismic acquisition, 3D seismic survey outline. So you can see it here, where they're basically trying to better understand kind of the reservoir development and the geology in place and what's kind of moving between when it comes to coalescence, kind of better understand the areas where the oil is produced and kind of in relation to original oil in place. Seismic acquisition, 4D seismic is seen here in the picture. Again, they're kind of trying to better understand from a technical point of view how to exploit the asset, how the asset is developing when it comes to drainage. They do two 4D seismic surveys completed in 2023 over the pads and in the local areas, pad 123 and 102S. They have representative well cross-section here, well location map, so you can see kind of the different well locations and a type of horizontal wells on pad 101 and pad 7 where they do representative well cross-sections. And now we can see those cross-sections, so you can see the gamma rays and the petrophysical analysis here. And basically the idea there is to capture where the sand is located, the different kind of locations for the upper Wabasca, lower Wabasca, McMurray, top continuous reservoirs. And you really want to start landing kind of at the lower base of the kind of McMurray formation, I guess, and have that 5 meter towards injector and then utilize that pay. You can see kind of the elevation readings here is between the, I guess, that well 270 and the top continuous reservoir is CSI is 310. So that tells us that those reservoirs could be a 30-40 meter thickness. So exploitable bitumen-in-place methodology, how do they know what's EBIP, exploitable bitumen-in-place? And it's defined in each well by top and base of the continuous reservoirs. You can see kind of the McMurray formation and the exploitable bitumen-in-place reading. You can see kind of the base and the top section. And based on those kind of readings, you get maybe 320 meters and 270, if I'm not mistaken. So again, 40, 50 meters here. Continuous, so basically it's defined as each well by the top and base of the continuous reservoir, and it's selected at the base of continuous sand unit, either developed or most likely to be developed. So continuous reservoir base, lowest portion of the continuous reservoir sandstone with bulk mass fraction, cut off at 6%. So they have kind of like a range, and they're looking at mud breccia in the lower portion, and they do cutoffs of what's recoverable. Upper lean, middle lean, and gas zones that are in pressure communication with the continuous reservoir are included, with no thickness cutoff. So some information here about how they calculate the exploitable bitumen-in-place methodology, and basically able to say what's the original bitumen-in-place and how much bitumen you get, like recovery factors, and what could be kind of derived from that. And again, sometimes people will say, well, this asset will have that much resource. This asset could have another number of resource, but sometimes it's kind of up to geoscientists on how to kind of calculate that and based on their assumptions. So as we're looking at the summary for pad performance and reservoir properties, we can see basically the pad number, the hydrocarbon area that they cover in meter squared, continuous reservoir thickness, and that's again in line with what we talked about. Some reservoirs are about 58 meters, which is remarkable. Some reservoirs are 30 meters. Porosity roughly 32-33%. Average permeability is 4 or 5 or so Darcy. Some they have like 3.3 Darcy. Average permeability in kV, so Z direction, will be 2, 4, so that's pretty good. That's not bad. In oil saturation, 76%, 71%, 78%. EBIP, which is what we just talked about, you can see the number in 1,000 cubes. And recovery to date, you can see how much was recovered from that, and then the expected ultimate recovery, so EUR. So basically, we can see some recovery to date of some pads that are 44%, 71%, but the ultimate recovery percent will be 78, 89, 98. And so what the team there does, they're looking at kind of what was recovered to date, and if they can achieve the ultimate, the expected ultimate recovery, sometimes they could exceed that number. But you do have pads, for example, like 111, that is currently at 5% recovery to date as of that date. So now it will be maybe like closer to double that, maybe 10% or 15%. But the ultimate recovery on that pad will be 81%. So there will be a lot of time to continue steaming that pad and keep kind of going on that path to get that pad kind of to the expected ultimate recovery, which is the next maybe 10, 15 years. Here's a little bit more pads. We can see some younger pads as well, pad 125, 126, 119, only at 2%. So those will be fresh new pads. And so that kind of goes back to what I talked about, is that they will bring new pads online, mostly kind of on that west side. But then the NCG co-injection will be taking place at legacy pads. So they're able to allocate that steam efficiently and therefore lower the steam to air ratio as indicated before. And here we can kind of start zooming in to some of the co-injection overview, co-injection areas, as seen here in the co-injection overview, where the legacy pads in blue are basically being NCG co-injected, so non-condensable gas, and kind of the west, more south part of the newer pads is getting steamed, and it has very low recovery factor as of today, and has a lot more time to keep going. And so if we take, for example, pad 101, which is currently being NCG'd, and if we will go back to pad 101, we can see in this pad that it's a very mature pad. So that will be the first row. The recovery to date on that pad is 83%. It's probably closer to 90% by now, but the expected ultimate recovery is 98%. So that pad will have to be NCG'd, so non-condensable gas, and seeing those basically steam to oil ratio declining, but also oil production will kind of decline over time as the expansion of the steam chamber is no longer vertical, it's more kind of like lateral as it coalesces with other pads as well. If we take maybe other example here, let's say pad 116, which is kind of the last pad on this list, and we'll take a look pad 116, so that will be the third row from the bottom. Yeah, sure, the recovery to date is 65% as of end of 2023. Could be now closer to 80%, maybe 75%, but the expected ultimate recovery is 84%. So obviously they have to reduce steam utilization, reallocate that steam to newer pads, and NCG co-inject in that area. Now, what else we see on this pad is it has one of the lower permeabilities on the vertical side of things. And so that tells me things are slowing down significantly on that pad, and they have to NCG, especially as it coalesces with other chambers as well. So it kind of gives us a good idea of non-condensable gas co-injection implementation at Firebag and the overall strategy. And that will continue over time as basically new pads will start seeing more steam, and pads that are kind of maturing into the recovery, kind of the ultimate recovery, the recovery factor that exceeds a certain threshold, those pads will start seeing NCG more and more. So co-injection overview. So NCG, in this case, so non-condensable gas, methane fuel gas, is co-injected with steam and has been implemented on 10 mature pads, which we just saw, since May 2018. And that tells me they have like a cutoff for recovery factor, and that's where they invoke the NCG co-injection. NCG and steam co-injection typically commence on a pad when estimated ultimate recovery has exceeded 65%. So here, this is beautiful, right? So I'm kind of forecasting that there is a threshold, because that tells me they kind of invoke, and they tell us 65% recovery. So if we don't see a pad on this list, for example, and if we look here, let's see something mature, maybe like pad 110. Do we see 110 here? No. So pad 110 is not here on the list yet, but pad 110 at 46% recovery factor as of end of 2023, maybe by now it's the end of 2025, this pad is getting closer to 60%. We should expect seeing pad 110 basically seeing NCG co-injection in the future, and we should expect it in the next update in the next couple of years when I do another one of those presentations to see that pad kind of seeing NCG co-injection, right? And it will be kind of more and more integrated kind of towards that late life program, where newer pads will be seeing the steam that comes from that pad and basically reallocate it. And that's how we derive that entire non-decline of the asset, essentially, where the production as of today is at 245,000 barrels per day, and it's only increasing towards 250. It's not declining, and that tells you how they're able to allocate that steam from one pad to another as the co-inject NCG. A little bit more here about NCG, geological characteristics, SAGD performance optimization approaches and surface infrastructure are also considered when evaluating timelines for NCG co-injection. And of course, that really tells us that once they see something that's complex geology, things like that, where the SOR is really increasing significantly from the baseline SOR, they have to NCG co-injection, because that indicates inefficient kind of utilization of steam. Some of the main factors considered to determine, execute, and monitor NCG co-injection rates involved monitoring reservoir responses and main key performance indicators. And as I mentioned, one of those is probably SORs, right? Steam to oil ratios. Field-wide strategies to cut steam from mature pads and replace with NCG, and that's exactly what I talked about. Maintain the desired chamber pressure for the mature pads. Again, once you get coalescence between the steam chambers, if you inject in one pad, you inject a lot of steam. Once you drop pressure on a neighboring pad, that steam could be going to places you're not intended for it to go. And therefore, you have to co-inject NCG to maintain a balance between the bottom hole pressures in situ. NCG retention within the reservoir, considering the balance between NCG leakoff and volume of the NCG produced back. So they're really controlling kind of the material balance when it comes to NCG co-injection. And sulfur recovery unit capacity limit to handle the level of producing gas at the field level. Obviously, like any other assets, they will be constrained by a certain surface facility volume. In this case, sulfur recovery unit capacity to handle the produced gas at the entire field level. So as we start looking at some co-injection impact from some of the pads, so you can see NCG co-injection performance at pads 101, 1 to 109 to 116, we can see trickling down the well production, and that's expected, like what we talked about, because the steam utilization, the incremental steam utilization doesn't provide the same benefit, and therefore SOR must increase. But because they co-inject NCG, they're able to drop that steam, in this case, from 60,000 cubes per day towards 30,000, so that will be a 50% drop in steam utilization, and drill new pads, drill new well pairs, and reallocate the steam accordingly. Therefore, SOR is maintained at very good levels, just between 2.2 to 2, and average chamber pressure is also maintained. So that tells us that that's one of the KPIs to maintain the bottom hole pressure, and the chamber pressure between 2,000 to 2,500 kPa. There have been no observation of negative impacts on oil rate after NCG co-injection other than due to natural decline. And again, one could say, well, the oil rate is declining. Of course it will decline because now you're on the lateral expansion of the steam chambers, not vertical expansion. So oil rate is no longer glowing, it has to trickle down. So, but on the overall asset, because you reallocated that steam, you're able to maintain overall asset non-declining oil rate, even though on the well per basis, you will be decline or trickle down. Continuous reduction of steam injection rates, as we can see in this in the charts to the right. Steam reallocated to younger pads, as I mentioned several times earlier today, unable to increase NCG injection and further cutting steam in 2022 due to reaching the gas handling capacity limit. And again, as we said, there are limits, constraints on some of those facilities, if not all of them. And there is a certain amount of kind of development program, new pads integration, and NCG co-injection and late life pads. And you gotta really use smart strategies to close that energy and material balance between all of those pads to make sure that the handling capacity limit is not being exceeded. SOR generally has a decreasing trend, except recently, as explained above. Maintain the decreasing trend in reservoir pressure targets by NCG co-injection. Co-injected NCG with steam in the range of 0.15 to 0.35 mole fraction during the reported year, and gradual increase in produced gas from reservoir. 40% of injected NCG is produced back, so they're keeping some of that NCG to maintain the bottom hole pressure. And no significant temperature reductions have been observed within existing steam chambers from observation well temperature pressure data. And that really speaks to the fact that the steam carries a significant amount of energy with it to drain the oil by gravity by transferring that heat. And so they're not seeing significant temperatures decline. So NCG does not have an effect where it basically kind of steals in a way the enthalpy from the chambers and cools it. So what we're seeing here is almost like NCG could carry that heat to other portions of the reservoirs and maybe transfer that heat so oil can be drained by gravity. The problem there is, of course, that NCG by definition is a non-condensable gas, and steam chamber growth is questionable because in porous media, once you're not condensing, you basically could have a choking effect. And so that's why we're not seeing production necessarily increasing in green, but we're seeing production trickling downwards and kind of declining. So let's talk a little bit about surface facilities. So here you can see an overview of built and planned surface infrastructure. There have been no modification to the CPF, so central process facilities, during the reported period. Now, what this basically alludes to is that central process facilities, they, at the front end, you need injection capabilities of steam injection, and you need to generate, basically, if you produce 250,000 barrels per day, you need to, at SOR2, you need 500,000 barrels a day of steam. In their case, you need about 620,000 barrels of steam to be generated daily to be injected to the reservoirs to produce that oil. So they're basically saying no major modifications for that period. Bitumen and steam annual rates, you can see here how Firebag averaged 35,455 cubes a day for the time period to 217. And my recently reported numbers as of end of 2025 is is basically production of 244,000 barrels per day for the month of September, production of, month of October, 246,000 barrels per day, closer to 247,000 barrels per day for the month of November. And that SOR is 2.5, which basically yields steam injection rates of 627,000 barrels per day of steam. And so that's very close to 100,000 cubes a day, as you can see in this picture. So here we have 93,570. That tells us that between that time frame to the end of 2015, they were able to introduce another 7,000 cubes of steam to be injected. But in the December timeframe, we can see they already achieved that. So that tells us basically no new facilities were added when it comes to steam capabilities to Firebag, which tells us that everything you see today, the SOR reduction, the uplift in oil production, it's all from optimizations at Suncor. So here we have some future indication from 2023-2024 timeframe that no well suspension or abandonment activity is occurring during the reporting period. This is very different from conventional kind of wells, legacy wells. Some people could say, oh, they're not abandoning any wells, but reality is those are active well pads, very low reserve life, a very high reserve life, life reserve index, RLI, reserve life index. And the reality is the legacy well pairs and pads are seeing NCG co-injection. So they're very active and they're trickling oil production rate. So there's no reason to abandon anything here. Everything is pretty much active. Now, this is not to be, as I mentioned, not to be confused with conventional operations where the well, when it's basically not performing, you abandon it. But here, as we have a coalescence of the pads, the entire field is basically being managed on the steam to oil ratio metric, and bottom hole pressure is being maintained. There's no suspensions or abandonments, and that's one of the benefits of SAGD operations. So they were also kind enough to share with us regulatory operational changes and key learnings. They tried different startups at pads 125, 126, so those will be the newer pads with their same steam injection. And what they're talking about here is that they try and kind of different circulation methods. And here they say combined circulation and bullheading methods have been applied to new pad startups over the years. And what they're alluding to is that when you start the SAGD process, you need to create communication between your injector well and production well. You will have roughly 5 meter kind of difference between them, but the bitumen there and the structure there really naturally is like a hockey puck. So you got to kind of melt it down and create this initial communication. So then from the injector, you can start injecting steam and produce that kind of emulsion as you develop the steam chambers by gravity towards the producer. But you need that initial communication. So what they're telling us here is that bullheading requires less cumulative steam to achieve the same reservoir heating as a circulation. This reduces CSOR and emissions produced, so cumulative steam to oil ratio. So what they're talking about is that basically they're injecting significant amount of heat and bullhead towards the injector to create that initial communication with the producer. The alternative is really circulation of both producer and injector to create heat, kind of transfer that heat and get to closer to 200 degrees to create that communication. So they tried basically several techniques on how to circulate new methods, and that really speaks to their ability to create lower to steam to oil ratio. And they're basically alluding to here saying, look, we're trying different methods and we reduce the cumulative steam to oil ratio and emission produced because we're trying different kind of startup methods in a way. They had planned turnarounds, successful turnarounds at Plant 91 and completed maintenance work. And they're also doing extra low intensity thermal extraction method called ELITE, a process that could improve energy efficiency of SAGD by significantly lowering operating pressure and temperature. So that's really kind of an exercise around maybe not injecting as much. We do know that bottom hole pressure, kind of injection to bottom hole pressure correlates often with oil production rates. But it seems like maybe they've done some simulation work, maybe some pilots to see that maybe lower enthalpy injection for their kind of elevation where they're located and lower bottom hole pressure operating conditions could be more beneficial when it comes to kind of having extra low intensity thermal extraction process. This could be explained by the vapor pressure curves and drainage and kind of strategy, and when you invoke this process, I have a hard time really seeing that happening during the vertical phase when they produce the oil initially, but maybe like midlife towards kind of end life, they could integrate that elite strategy where they may be not injecting as much heat, maybe integrate NCG and maintaining lower bottom hole pressure. And so they tell us here 2-year pilot project began in 2021, wrapped up in December 2023. Performance was consistent with pre-pilot expectations. Those expectations are typically made based on reservoir simulations, which is what I specialize in. So when it comes to another regulatory operational changes technology update, you can see they're trying something that's called ESXD. So basically, when you inject steam, you could co-inject condensable gases or condensable liquids with that steam that getting vaporized, obviously, and being injected. So those are non-condensable gases. So those will be maybe like solvents. And what they're telling us here that for PED 131, they do ESXD. So PED 131 designed as an ESXD pad commercial demonstration, equipped with the dedicated test separator, horizontal vertical separators, and instrumentation. They do comprehensive surveillance program, which started with SAGD baseline in March 2022 towards January 2023. All 8 well pairs are co-injecting HT mud, which is basically hydro-treated makeup diluent. This will be like a pentane hexane molecule, C5C6 basically. And this is kind of a solvent co-injection process. And target hydrocarbon co-injection concentration is about 10 vol% from that steam injection mixture. Planned duration of co-injection is 2 years, so end of February 2025. So they should have ended this program in 2025. And oil rate uplift and SOR improvement post-solvent injection was observed in PED 131. Solvent recovery is expected and monitoring is ongoing. So in my experience, typically those programs that take a long time to kind of understand the KPIs, get all the readings, all the measurement programs, and close the material balance. So that's kind of what they're attempting to do here. And what we see here, we see basically a small uplift in oil production rate, as they show us in the chart. Bitumen rate increased, but again, this could be a function of maybe operational conditions. So this is something to be mindful of as we go forward, because there could be an incremental cost associated with that solvent co-injection. But let's see what we hear from them in kind of recent updates, and I will be the first one to share it with the community online to make sure we better understand how that hydro-treated makeup diluent is being utilized as part of SAGD co-injection. This will be one of the final slides. Future plans, 5-year outlook. So you can see kind of their development program going more towards west, towards kind of those new yellow pads, 132, 136, 126, 120, if I'm not mistaken. So a little bit more kind of south. But you kind of get the idea that they're trying to kind of tackle more nice pay reservoirs, as we showed in previous slides, and really continue the development program as they integrate steam and utilize NCG co-injection in their legacy pads. So as I conclude this presentation, and hopefully you guys enjoyed it, give me a like on YouTube if you watch it on YouTube, and hopefully you kind of enjoyed that. I know it's a little bit more technical, but I think it's important to communicate what these companies are up to and what kind of technologies they utilize. And this is really, Suncor is one of the more important and bigger companies in Canada when it comes to oil production. They do a significant amount of refining as well. They have a retail business where they sell basically gasoline, among other products. But I think it's important to kind of understand from a SAGD point of view, and the fact that this asset been communicated as their crown jewel asset, where Suncor's Firebag asset currently stands. So several conclusions here. We can see development in new pads, new well pairs. We can see growth in new well pairs. So currently the amount of well pairs, I think it's about 340 producers or so, roughly 380 SAGD injectors. Production is about 246,000 barrels per day. SOR 2.5, which is excellent. Water cut 73%. We can see significant non-condensable gas co-injection. We can see them trying different solvents. So what I just updated about, and really they're trying to kind of manage their field in a way where the asset production does not decline. So it does not decline, as you can see in the green chart. The production is only increasing towards 246,000, 250,000 barrels per day, and they're very proud of this asset being one of their crown jewels, and we can see why, because there is very good productivity per well. So production per well is about 700 barrels per day. Again, this number could be a little bit tricky because the way they report maybe the wells, it could be lower, but that's kind of what I'm seeing from my side. But nevertheless, very good productivity from the top performing wells, which are typically the new pads that come online. They have the higher basically production rate, the highest production rate, and the fact that they have only 340 producing wells and the entire asset producing 250,000 barrels per day tells you there is very good productivity on that asset. So long story short, thank you so much for listening to this. Hopefully you extracted a lot of value here. And yeah, let me know if any other assets you want to learn more about. And I was very happy to do this for kind of Suncor's Firebag overview. So thank you all very much, and we'll see you